Hey, what's up? It's your old pal, Mr. Cook, and we're going to do the 2.6 fundamental theorem of algebra problems. All right, so for this we need to find all the zeros for the different polynomials that we have listed here. So a really good and helpful tool is going to be your graphing calculator if you have one. If you don't have one, get one. It's really helpful. It'll help you out throughout the rest of the year and for every math class or science class that you're going to take from here on out. So, I don't know. That's just kind of my little endorsement for it. Anyways, to find all the zeros, the easiest way to do it is to graph it out and use synthetic division on the zeros to show work. Zeros are, the same thing as x-intercepts. That's all that they really are. So in other words, we're looking for the x values that give you a y value equal to 0. That's ultimately what we're looking for. So if we graph it out, like even this first one right here, graph it out, y equals x to the third plus 8x, plus 8x squared plus 15x. All right, and then hit graph. So where does it look like you have x-intercepts? Looks like we have one at 0, -3, and -5. So you can even check to see if they're x-intercepts by hitting second and then graph. That brings up a table, a t-chart. You can check those values out for yourself. At 0, 0, we have an intercept. At -3, 0, we have an intercept, and at -5, 0. They're all intercepts. As long as the y value is equal to 0, we've found our zeros. So you already know what they're going to be: -5, -3, and 0. So to test out a 0, to show work, in other words, use synthetic division. So we're just going to use the first one, I guess, that I saw, 0. So I'll plug 0 into the corner and test out this to make sure it's a 0. Use the synthetic division algorithm, so we have 1x to the third, 8x to the second power, 15x, and then we don't have any constant value, so we're going to put a placeholder for that 0 over there at the end. Okay, so then we drop down the coefficient, lead 1, 1. 1 times 0 is 0, 0 plus 8 is 8, 8 times 0 is 0, 15 plus 0 is 15, 15 times 0 is 0, and sure enough, we get a 0 as a result. Our remainder is 0. That's what we're looking for. That's how you show work for this. Okay, and then we can continue on with synthetic division. Just, these are the new numbers that we're going to use, and we're going to use another one of the zeros, -3. Okay, so again, just another x-intercept that we have, -3, 0. That's what we're using here. So you put -3 in the corner, and just trust your synthetic division algorithm. So drop it down, 1, -3 times 1 is -3. 8 minus 3 is 5. 5 times -3 is -15. And as our remainder, again, we get 0. Okay, so that's another 0 that we get. Now let's check the last number that we had on our table, which was -5. So we're going to plug -5 in for synthetic division and verify that, again, it's a 0. So under the last number should be our remainder box, and let's see that we get 0. Let's check it out. So drop down the 1. 1 times -5 is -5. -5 plus 5 is 0. So check it out. Those are our zeros. 0 there, 0 there, 0 there. So in other words, our values are x equals 0, -3, and -5. That's the fundamental theorem of algebra, that you can use synthetic division to prove that you have x-intercepts. Okay, let's do the same thing with number 3. There's even like a process that you can go through that's pretty easy. Graphing it out should be where you start. But if you don't have a graphing calculator, I'm going to show you how to do this as well. It's not as easy, but it's still not that bad. What you do is you start off by doing something called the rational roots test. So you take the constant value, which is 7, and lead coefficient, and if there's not a number there, it's 1. So 1 is our lead coefficient. And then you just list off all the possible rational zeros that you could have. So 7 goes on top, the constant value goes in the numerator. In the denominator, you get the lead coefficient, so that's 1. And then you just simply list off all the factors of the top number and the bottom number. So the factors of 7 are 1 and 7. The factors of 1 are just 1. So that means that all these numbers that we could potentially have for zeros are going to be plus or minus the combinations of the fractions that you can make with any of the numbers that you have in the bottom as your denominator. So 1 over 1, so 1 plus or minus 1. And then 7 over 1, which is 7, so plus or minus 7. So in other words, out of all the numbers that you could possibly think of, the only ones that might give you 0, in other words, give you a 0 for your answer here, or an x-intercept, the only ones that could possibly be your x values would be one of these ones, one of these 4. Positive 1, -1, positive 7 or negative 7. So those are the ones that you're going to have to check with synthetic division. So, without the aid of a graphing calculator, you're kind of flying blind, and you need to just plug those numbers in. So let's just start with the beginning, 1. Okay, so plug in 1 and see if 1 works. So we have 1x to the third, 9x squared, 15x, and 7 as our constant. So the only way that this will be a 0 is if our remainder is 0. So let's test to see if 1 works there. So 1 times 1 is 1, 9 plus 1 is 10, 10 times 1 is 10, 10 plus 15 is 25, and then 25 plus 7 does not equal 0. So 1 is not one of our zeros. So out of all of our combinations of numbers that we could use, so remember 1, negative 1, 7, negative 7, 1 doesn't work, so we can just cross that one off. Now let's try negative 1. So 1 times negative 1 is negative 1. 9 minus 1 is 8. 8 times negative 1 is negative 8. 15 minus 8 is 7. 7 minus 1 is negative 7. So check it out. Negative 7 plus 7 gives us 0, so that means that one of our zeros is negative 1. So we already found one of them. There's going to be a grand total of 3 of them because we know that the degree is 3, and that's how many zeros we're going to end up with one way or another. Once you find one of your zeros, and if you don't have a graphing calculator, one thing that you should always do is check that number and see if it works again with synthetic division. Again, to find a 0, the remainder, the number at the very end, needs to be 0. Let's see if this is the case. So 1 times negative 1 is negative 1. 8 minus 1 is 7. 7 times negative 1 is negative 7. And yeah, look at that. 7 minus 7 is 0. So that means that negative 1 works again. I guess let's try it again, see if it works. Negative 1. All right, so the 1 drops down, and then that's going to be where our remainder is. Let's look for 0 there. So negative 1 times 1 is negative 1. 7 minus 1 is not 0. So that means that we've run out of luck, and we've only found 2 of these zeros. But we've at least eliminated another one of these potential numbers that we could use because we've exhausted that one as a 0. So the only other options are either 7 or negative 7. Let's just go with the next one, 7. Put that in there. So if we do 7, 7 times 1 is 7. Does 7 plus 7 gives you 0? No. So that one doesn't work out. Now let's check the last one, negative 7. So we plug in negative 7 here. 1 times negative 7 is negative 7, and check it out. 7 minus 7 gives you 0. So that means that our last 0 is negative 7. Now that's 1, 2, 3 zeros, just like what we predicted, but there's a unique case here, and that's that negative 1 is used twice. What we do is we call that a multiplicity. However many times that negative 1 shows up as a 0, that tells us the multiplicity. So that means that for our solutions, we write it out formally like this. Negative 1 with a multiplicity of 2 because it's used twice, and then also negative 7 is our last 0. So that gives us 1, 2, 3 zeros. Okay, so that's how you can do it by hand. I'll do one more example by hand, and then the rest of them I'm going to use my graphing calculator just because it goes by a lot faster. So for number 5, again, assuming I don't have a graphing calculator, I'm going to do the rational zeros test. So I take the constant value and the lead coefficient, which again is 1, and I list the constant on top, the coefficient in the bottom. The factors of 28 are 1, 2, 4, 7, and 28. Oh wait, and 14, my bad. So 14 is also in there. And also 28. And then the factors of 1 are just 1. So let's make the combination of the fractions. So we have 1 over 1, which is 1, so plus or minus 1. 2 over 1, which is 2, so plus or minus 2. 4 over 1, which is 4, so plus or minus 4. 7 over 1, which is 7, so plus or minus 7. 14 over 1, so that's plus or minus 14, and then 28 over 1, so plus or minus 28. Yikes. So that's 1, 2, 3, 4, 5, 6. So 6 positive zeros and then 6 negative zeros. So a grand total of 12 numbers that we're going to have to test. So this is why it's just helpful to have a calculator because, you're just looking for these 3 zeros and you have to test potentially 12 numbers to get to that point. Well, so that's when you have to develop a couple of other methods to go through this. There's one method that I like to use that works out pretty nicely when you don't have this, and that's just to check to see if 1 is a 0 or not. And you get that by adding up the coefficients. If they equal 0, that means that 1 is going to be one of your zeros. In this case, that doesn't happen, so it's not going to be able to show. But let's see here. Are there any ones that are going to do that? Yeah, I think number 11 will. So I'll show you that trick when we get onto the second page. Anyways, so for this one, we just kind of do what we can. I'm going to try 1 first just to show you that it's not going to work out. So 1x to the third, negative 6x squared, negative 2x, and then 28. We should get 0 in the denominator if it's a 0. All right, so we drop the 1 down. 1 times 1 is 1. 6 minus 1 is negative 5. Negative 5 times 1 is negative 5. Negative 5 and negative 2 makes negative 7. Negative 7 times 1 is negative 7. And obviously, 28 minus 7 does not equal 0. Okay, so that doesn't work. All right, so positive 1 is not an option, so we cross that one out. Let's try negative 1 instead. 1 times negative 1 is negative 1. Negative 6 and negative 1 makes negative 7. Negative 7 times negative 1 is 7. 7 minus 2 is 5. 5 times negative 1 does not cancel out 28, so that's not going to be the one. Okay, let's try 2. 2 times 1 is 2. 2 minus 6 is negative 4. Negative 4 times 2 is negative 8. Negative 8 and negative 2 makes negative 10, and that's not going to cancel 28 either. Okay, so 2 doesn't work. Let's try negative 2. All right, 2 times negative 2 is negative 2. Negative 2 times negative 2 plus negative 6 is negative 8. Negative 8 times negative 2 is 16. 16 minus 2 is 14. 14 times negative 2 is negative 28. We found one. Okay, so negative 2 is one of my zeros. X equals negative 2. That's one of my zeros. Awesome. We just need 2 more, and we're done. So let's try and see if negative 2 works again. I don't know if it's going to. In fact, I doubt it. But let's find out. All right, 1 times negative 2 is negative 2. Negative 2 plus negative 8 is negative 10. Negative 10 times negative 2 is 20. And then that's not 0. Okay, you know, this takes a long time to find all of them, to just keep bringing them down like we did over here without a graphing calculator. It's really nice to know what your answers are ahead of time, so that's why it's helpful to have that graphing calculator. But in this particular case, it's just going to take a long time. So you know what we're going to do? Let's improvise. Let's do something different. So we would have to just continually use synthetic division over and over again, and that sucks. So instead, what we're going to do to find our answers, to find our 0 values, is we're just going to use the fact that this is now turned into 1, 2, 3 numbers. So that means that this is a quadratic because I have a constant, an x, and an x squared for this polynomial. So 1x squared minus 8x plus 14. And we're going to find the zeros by hand. So we're going to try and factor this, or we're going to try and use quadratic formula. But ultimately, to find a 0, you just need to find out whenever this quadratic is equal to 0. So let's see what we get. So the a value is equal to 1, the b value is equal to negative 8, and the c value is equal to 14. We plug it into the quadratic formula, and we get negative of negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times c all over 2 times 1. Okay. So the negative of a negative is a positive, so we get 8 plus or minus the square root of negative 8 squared is 64. Negative 4 times 14 is negative 56. Yeah, negative 56. 64 minus 56 is 8. So it's square root of 8 all over 2. All right, so we can reduce this a little bit further. Okay, let me stop there. If you came up with this radical right here, this expression, since 8, you can't take the square root of it evenly, this would give you your other 2 zeros. Because this is 2 answers. It's 8 plus square root of 8 over 2 and 8 minus square root of 8 over 2. 2 separate numbers altogether, and those end up being the other 2 zeros that you're looking for. So it wouldn't even have been in these rational zeros because they're not rational numbers. So the 2 other zeros that we were going to have were going to be here. So think about how crazy that is. I could have used synthetic division here and kept using all of these numbers, and I still would have ended up with not getting any of those and having to use quadratic formula. So here's an idea for you. Find one of the zeros, either by using your graphing calculator or using these numbers. And when you get down to a quadratic, 3 numbers from synthetic division, just use quadratic formula or factoring. It's really, really easy, and it finds these answers without plugging in a ton of other ones. Anyways, so that gives us our zeros, negative 2, and then also 8 plus the square root of 8 over 2, and lastly, 8 minus square root of 8 over 2. So those are all 3 of our zeros. All right, so I'm going to have a separate video for the back page where we're going to use just the calculator, and that should go by pretty quickly.